Okay, the last example is a cotangent function, which is the exact same technique as a tangent function. Only difference is where the asymptotes and the plus b's and minus b's. In fact, you know what, the only thing is different is the asymptotes, honestly, because the first and fifth are still plus b, the third and seventh still minus b. You'd find if you're in the first quadrant, tangent and cotangent of 45 or pi over 4 is the same. Tangent, cotangent, 3 pi over 4 is the same. What's different is where the asymptotes are. So if we went back here and I kept the plus b's and the minus b's where they were and switched the zeros and the asymptotes, just to give you an idea. So if I were to draw an asymptote here and here and here, and I put a 0 right here and keeping the plus and minus b's the same, now that's where cotangent would be. So I mean, that's the difference, is where the asymptotes are. It creates, you know, the graph looks backwards and it also starts at a different spot. So that's kind of the differences there. So everything's the same as far as the stretch constant period. We're going to do the x and y axis the same way with 8 equally spaced dashes. We're going to find the per dash the same way. We're just going to put the asymptotes at 0, 4, and 8 instead of 2 and 6. We're going to put the zeros at 2 and 6 instead of 0, 4, and 8, and then the b's and plus b's and minus b's go in the same spot, connect within the asymptotes. Okay. So 3 cotangent of x over 2. So we can see that b is equal to 3, which means my stretch constant is equal to 3, and positive b is equal to 3, negative b is negative 3. So 3 and negative 3 are the values on the y-axis centered at 0. I can see my period is going to be pi over a half, because c is equal to a half. Keep that in mind when there's x over number, that there's a 1 in front of the x, so 1/2. So the period pi divided by a half, also known as 2 pi. So per dash is going to be 2 pi over 4, which is pi over 2 again. So if I come over here and put x at a pi over 2 scale, so the difference again is where the asymptotes, where the zeros go, the plus b and minus b are the same. So according to this technique, I'm going to put an asymptote at 0, 1, 2, 3, 4, 5, 6, 7, 8. That's where the asymptotes go. And I'm going to put a plus b at 1 and 5, and plus b is positive 3. And I'm going to put a minus b, which is negative 3 at 3 and 7. 1, 2, 3, negative 3, 4, 5, 6, 7, negative 3. And a 0 at the only two left, which is 2 and 6. And notice that we started an asymptote and an asymptote, so we get the entire picture twice here. So again, it's going to have that kind of shape in the middle. Always on the side where it's going upward, it's going to kind of turn towards the asymptote and then up. When it's going downward, it's going to go towards the asymptote and down. And then it just continues up forever, continues down forever. Same deal here. Create that little curve really nicely and then go up and go down. And you don't have to continue it. I mean, you don't have to draw an extra one over here just to show it's going to do it again. If you really wanted to, you could. It would just start like this. Just kind of show that it's going this way like that. And, this one would be down here. If you wanted to put a little extra there, you could. I don't require this and this to be there, but just that's what would happen.